Hi, my name is Ahmed Mawali and this is my low-level interfacing assignment 1. In this video, I'm going to explain the operation of my code in the Accelerometer service. So my project folder directory is located in Zephyr project, Ahmed, and the name of the folder is BLE step count. So inside there's the SRC folder, which contains the main.c, the main application function, and the header file lsm303 and the .c folder, which has the lsm303 interface code. To function the accelerometer service in the microbit, there must be 4 important steps to be taken in the code, which is first initializing the accelerometer, which is lsm begin, then exchanging a byte with the register, which is read and write register, then read an acceleration in 3 dimensions x, y, and z, and finally initialize accelerometer and read and display x, y, and z acceleration, which is this one for the printf, and execute functions. So in like this, we start to extract the I2C serial bus. Then inside the LSM begin function, there's an integer called NAC and an assigned integer with 8-bit length called device ID. Then we set up the I2C interface by setting up a pointer to get the I2C underscore 1 device to the I2C device structure using the function device get binding. Then we say if statement, if I2C equal to null, then printf error requiring I2C interface and return -1. It's return 0 if it's successful and return -1 if it's an error or negative number. Then check to make sure the device is present by reading the who am I register. So NAC equal the function LSM read register, which read the known register value number within the LSM, which is 0f, and it should contain the value 0x33, and in decimal it's 51. Then we say if NAC is not equal to 0, then printf error finding LSM on the I2C bus and return -2, else printf found LSM and print the who am I register as an integer value, which is in this case it's 51. So this mechanism allows to check whether the device is actually on the bus. Then on the write register function, we wake up the LSM to maximum speed and all Excel channels. And so if all the LSM begin function works okay, then this will then set the operation mode of the accelerometer to ±2J range with the 12-bit resolutions. Then comes to exchanging a byte with the register with the 2 function read register and write register by reading and writing of single bytes from and to a register. So in line 170, we set NAC to the function I2C reg read bytes with the arguments I2C, which is a pointer to the device structure for an I2C, and LSM303XL address, which is the address of the I2C device for reading, and regnum, which is address of the internal register being read, and value is a memory pool that stores the retrieve register value. The Excel argument is defined in the header folder up here with the 0x19 address, and the reg num and the value is defined up here in the read register function as an assigned integer with 8-bit length. Then we return NAC. In the write register function, we declare a variable an assigned integer with 8-bit length array called buffer. Then we assigned a value to the 0 field in the buffer array and say int nac equal to the function I2C rig write bytes with the arguments I2C, which is a pointer to the device structure for an I2C, and LSM303XL address is the address of the I2C device for writing, and regnum is the address of the internal register being written. Then the value to be written to internal register is in the value argument, and return nac. So read an acceleration in 3 dimensions x, y, and z by using the function LSM303 read excel y. Then in line 132, it uses the function I2C burst read with the arguments I2C, which is a pointer to the I2C device. Then the LSM303XL address, we set it before in the header folder as 0x19 I2C address. Then comes to the A8, which is an internal address from which the data is being read, and it's different in the Z and X. So in X it's A8, and in Y it's A8, and in Z it's AC. Then there's a buff, which is a pointer to receive the retrieved data buffer. Then 2 is the number of bytes being read. In line 183, set Excel to buff1. Next, we set the Excel to Excel and left shift operator and 8. Means the Excel value is moved to the left by the number of bits specified by the right operand, which is 8 in this place. Next line, we set Excel. We add Excel with the register value we set before in line 131. Then after that will be Excel equal Excel over 16, means must shift right 4 bits, as this is a left justify 12 bits result. So now scale to m to the power of 3 over s times 100 and plus 2047 equal plus 2j. Finally return Excel 32-bit, and same for X and Z, same functions of the read Excel. Notice that the LSM read Excel combines the low and high bytes and scale them to a value of acceleration scaled up by a factor of 100. Now in the header file, we define the LSM303XL address in line 5 and int LSM begin and read Excel X, Y, and Z. Now in the main.c folder, we initialize accelerometer and then read and display X, Y, and Z acceleration. So in line 32, we hash include our header folder LSM303.h so that it inherits the functions we defined in there in the header folder. Next, in line 42, we define the custom service value with its GATT characteristic ID number by 128 bits UUID numbers, and the custom ID number here is 0. Next line is define the XXL with its ID, which is 1, and for YXL it's 2 and ZXL is 3, and we know that from here. This is the accelerometer service, my service 0, and x is 1, y is 2, and z is 3. Now we go back. So in line 47, here's the service definition for my service ID and XXL and YXL and ZXL. In line 80, we unassign an integer value with the 32-bit length called XXL lowercase. The XXL will be the GATT characteristic value that is being shared over BLE, and same for Y and ZXL. And here are the callbacks for the read XXL and YXL and ZXL in line 96, 97 and 98. So here is the accelerometer service definition and works by put the XXL ID .uuid in the btjat characteristics, and we only want to read the X acceleration. We don't want to write or notify in this area. So we say read XXL and null for write, and XXL that will be shared over BLE. So now we go to the callbacks where we can read and display our readings. So in line 285 we printf got an Excel read, and then we point at the value in the memory in the XXL. Then we return we pass the value back through the BLE stack again. BLE is XXL, we set it up in here in line 80, and then return 0 if successful, I think. Yeah, and return 0 if successful. So now we go to the main void and we say ERR equal to LSM303 low level begin function we set in the C folder, and if the whole Bluetooth initialization mechanism works okay, then we execute XXL with our read XL X function, and same for Y and Z acceleration. So now once we're done with the code, we go to our terminal, we cd to our project folder directory, which is Zafir project and Ahmed. Then we say was build then our project folder name, so now we build the code to our microbit. So once we're done, we say was flash. It says an error for some reason, but if we open our serial book terminal, it's working fine. So as we can see, the Bluetooth initialization works successfully, and it reads the who am I register as an integer 51. So now if we go to our phone and connect the microbit from the app BLE scanner, we should see our microbit is available. So we connect to it, and yeah, we can see in the GetTK term all our services are displayed. So if we go to our custom service 0, we can see that the getRead Excel are available here with the specific IDs. So the ID 1 should be the get Excel read, as we can see, and the ID 2 should be the Y read, and finally the ID 3 should be the get as Z Excel read. Thank you.